Okay, number 12. I want you to recall that, like, if you have an x to the 1/3, that means that this bottom number is the index on a radical, so you could call this the cube root of x. That's the idea that we want to keep in mind when we're working on this problem. So saying this has an exponent of 1/3 is the same as saying what is the cube root of 16x to the 4th y to the -3. And the next thing I have in mind here is that we have a negative exponent. And anytime you have a negative exponent, it has to move to the opposite level of the fraction. So like if you have 2x to the -2 power, that would have to become a fraction and call it 2 over x to the 2nd. Because as soon as it changes levels of a fraction, it becomes positive. And the same thing's true if I had 2 over x to the -2. If I just bring that whole thing up, I can call it 2x squared over 1, which would reduce to just 2x squared. So I kind of wanted to let you know about that because we have a negative exponent here. And so what this really should be read as then is the cube root of 16x to the 4th over the cube root of y to the 3rd, like that. So this particular portion, because it has a negative exponent, had to move down below a fraction. But it still has to be within a cube root symbol because it was up here in the beginning, so it needs to also be down here. So now we want to simplify if possible. And so we want to find the cube root of 16. And when you look back at that list of common cubes that we made the other day, it turns out that 8 is a common cube. So we'd call this 8 times 2 so that we could solve the cube root of 8, which is 2. And we wouldn't be able to do anything with this 2. The cube root of 8 is 2, but the cube root of 2 we don't know, so it stays inside the radical. And then for the x to the 4th, we're looking for how many sets of x to the 3rd do we have. We have one set, so we'll put that x on the outside, just one, and say, hey, we found one set, but we had a leftover x on the inside. And then on the bottom, we have what is the cube root of y cubed. How, do we have any sets of y to the 3rd power? And we sure do. We have one set, so we'll write 1y at the bottom. And that's your answer.